Dear students, I welcome all of you in the another session of traffic engineering and management. So in the last sessions, we have learned about various kind of surveys that are related with the volume and speed. Now there is another thing that is mentioned in your syllabus, that is travel time and delay surveys. So in this session, what we are going to cover is we are going to cover various aspects and important things related with the travel time and delay surveys. This is the second module that we have been discussing, and the name of the module is this: basic traffic flow parameter and traffic service. So in this session, as I have already discussed, what we are going to cover is we are going to cover the topic related with the travel time and delay studies. Fine. Let us begin our session. As the name suggests, it is travel time and delay studies. This is one more thing that was left for us to learn, that is called as cumulative frequency curve. See, whenever we plot a graph of cumulative frequency versus speed or percentage cumulative frequency versus speed, then that graph is called as cumulative frequency curve. And as we all know, it can be seen from the picture that cumulative percentage frequency is marked on the y-axis and vehicle speed is marked on the x-axis. See, this is the frequency and this is the speed. Now, you can see that these are the various percentage 0, 10, 20, 30, 40 up to 100. Now, this is the point that denotes 85. That is called as 85th percentile speed. So how can we go through the concept of 85th percentile speed is that the speed which is corresponding, this speed, see, corresponding to 85 percentage cumulative frequency in the cumulative speed distribution graph is called as 85th percentile speed. Let me repeat it once again for you people. Guys, see, this is the cumulative frequency curve and this is speed. These are various percentages and this I am marking as 85. So what I will do, I will extend this line and I will mark the intersection point and then I will plot the projection of that particular line on the speed axis. And this is where I will be getting a speed that is called as 55 approximate. So that is called as 85 percentile speed, 55 or it can be 54. So it is called as 85th percentile speed. This is also called as safe speed limit. So if anyone asks to you that which is the safe speed limit, then the safe speed limit is 85th percentile speed. Now what is the indication of the speed? See, now you can see this is the area that I am hatching denotes a thing that is called as, it is the speed below which 85 of the vehicles are passing the point on the highway, or only 15 percentage, see these remaining percentage values are 15, only 15 percentage of the vehicles exceed this particular speed. So this 15 percentage speed is called as 15 percentile speed, it is called as minimum speed. 85th percentile speed is called as safe speed limit. And there is another thing, that is this. Let me show it for you. See, it is like this. It is somewhere over here. See, if I plot the graph like this, then this point is called as 98th percentile speed, and that is called as the design speed of highway. So what we have learned in this particular slide is that the 85th percentile speed is the speed above which only 15% vehicles are traveling, or 85% of the vehicles are traveling below this speed. that is called as. Then comes the 15th percentile speed, that is also called as minimum speed. Then comes the 98th percentile speed, that is called as design speed of highway. So this is about the cumulative frequency curve. The reason behind teaching this particular thing is the number of examples that can be asked for this particular session. So numerous examples can be asked based on cumulative frequency curve. Let us discuss about the measure of central tendency dispersion. So there are three things, three methods through which you can measure the central tendency of the speed dispersion or distribution. First is called as arithmetic mean, that is denoted as x bar. As the name suggests, it is one of the methods to determine central tendency of the speed data. That means it is the average of the observed speed. Means if 20 plus 25 plus 30 plus 20 plus 45, total this much of speeds are there, then if we take the value average of this, that is called as arithmetic mean, and that is called as x bar. So this is one of the measures of central tendency dispersion of the speed. This is the particular equation for that, where the x bar stands for arithmetic speed, Fi stands for number of speed observation in the group, and Xi stands for the midpoint speed of the group. So this is how it can be understood. Done? Then comes the second method, that is called as standard deviation, that is denoted by S. See, the standard deviation of a group frequency distribution is given by the equation this. S is equal to, see it is like this, S is equal to under root sigma f d square summation. So it is like this. Now here the S stands for standard deviation, D stands for deviation of the average, that means x minus x bar. The approximate value of standard deviation can be obtained from, there is another equation for obtaining the approximate value of the standard deviation, and the equation is this, that is 85th percentile speed minus 15th percentile speed that we have already learned divided by 2.07. We have learned that P85 stands for 85th percentile speed and P15 stands for 15th percentile speed. Then comes the coefficient of variation, that is the third method. The equation for this is V is equal to 100 S by X bar, where the S is the standard deviation, X bar is the arithmetic mean, and 100 stands for 100 and V stands for coefficient of variation. So this is how the combination of these three equations can help you learn the measure of central tendency dispersion. Let us have the deep insights of these topics with the help of examples. This is the first example. The vehicle passes 1 kilometer of length road in 1 minute, 2 minute and 3 minute respectively. Find the time mean speed and space mean speed. We know that speed is equal to distance by time. If the first vehicle we take, then it is V is equal to d by t. D is 1 kilometer. T which is given over here is 1 minute. So what we have to do, we have to convert it in the kilometer. So it will be 1 by 1 by 60. So this will be, the speed for first vehicle will be 60 kmph. Then the second will be 30 kmph because that is 2. Then comes the third, that comes 20. See it is like this, d by t. For first vehicle it is 1 by 1 by 60. For second vehicle this is 1 by 60, 2 by 60, and third it is 1 by 3 by 60. 3 is the minute and 60 are the total minutes of the hour. If you want to convert the minute per second into kmph, then this is how it can be done. Then comes, let me erase all these things for you so that it can be easier for you to. First is the time and speed. The equation for time and speed is this summation vi by n. So we have the speed for that 60 plus 30 by 20. We have the values and we can calculate it by this thing. So what we will do, these are the particular errors that have been occurred. What we will do, we will cover this in the last slide. Then this is the another example. Forget about the first example, the example that I have taught before this. Spot speed studies were carried out. These are the spot speed studies. Now you have learnt about the modal speed, median speed, design speed, standard deviation, coefficient of variation. So what you are supposed to do over here is you are supposed to calculate all these things. See, you have to calculate modal speed, median speed, time mean speed, design speed, traffic calculation speed, standard deviation, coefficient of variation. So let us learn one by one. We have been given the values of speed. We can get the value of mean by dividing it by 2, 0 plus 10 by 2, that gives us the value of 5, 20 plus 10 by 2, 15, 30 plus 20 by 2, 25, and this is how it can be achieved. Then frequency is also already been given. Both of these things are given. We have to calculate first this, then this, then this. Fine? And then this. First mean speed you can calculate by your own. Frequency you can calculate that, okay, if 850 vehicles are there and total 12 are traveling, then if 100 are there, then how many? So it will be 1200 by 850. So it will give you the value of approximately 1.41. Then you can get 2.12 for this, 8, 10.47, 24, and this is how you can get this. Now, how we can get the value of cumulative frequency? 1.41 will be as it is. Then you have to add this value and you will get this value. In this value, you have to add this value, you will get this value. In this, add this, you will get this. So this is how you can get. Let me do it very clear. 1.41 plus 2.12 will give us the value of 3.53. 3.53 plus 8 will give us the value of 11.53. 11.53 plus 10.47 will give us the value of 22. 22 plus 24 will give us the value of 46. 46 plus 30 will be 76. 76 plus 14 will be 90. 90 plus 5.06 will be 95.06. Then 95.06 plus 3.88 will be 98.94. Then 98 plus this is some kind of error, I guess. This is how it can be achieved. And then we have to multiply this f with this. 15 into 18, 270. 25 into 68, this. So this is how it can be got. Then what we'll do, we'll plot the graph of cumulative frequency versus speed. So it would be looking like this. First is modal speed. Modal speed stands for the speed having the maximum frequency. We have learned this thing. So we can, if you draw, this is the sample chart. If you plot the chart of cumulative frequency percentage over the speed, you will get that maximum vehicles are traveling with the speed of 55. The modal speed would be 55. Then you can also get the value from this chart also. See, modal speed is the medium speed. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is how 55 can be got. Then comes median speed. Median speed stands for the 50th percentile speed. See, this is the new thing. The 50th percentile speed is called as the median speed. And if you plot the graph, you will get it as 47 kmph. Then time mean speed, what you will do? 42970 you are having total speed. 850 you are having total this summation f value. See, it is like this by this, and that will give you the value of this time mean speed. Then comes the design speed. Design speed stands for the 98th percentile speed, that will be 84. You have to plot the graph like this. If you plot, you will get it like 84. Then comes the speed for regulation. Now there is another word. 85th percentile speed is called as safe speed limit. It is also called as speed for traffic regulation. So this is the new thing that you are learning over here. So if you plot the graph of 85, then you will get like this. It will be approximate 60 kmph. Then comes the standard deviation, that is P85 by P minus P15 by 2.07. We have the values of P85, P15, and this will be 14.49. And then comes the coefficient of variation. It will give you the value like this. You just have to put the values over here. So this is like it. Now let us discuss about the another example. On a highway, there is a car per minute traveling at the speed of 120 kmph, and there is a truck that is traveling at the speed of 60 kmph. So car is having the speed of 120, truck is having the speed of 60. The volume is two vehicles per minute of 120 vehicles per hour. Calculate time mean speed and space mean speed. It is as easy as that. You just have to add the value of speed and divide it by the total number. You will get it as 90. And if you do the inverse of this thing, that will give you the value of space mean speed. Means what you have to do? 2 by 120 plus 60. And this is how you will be able to get the value of space mean speed. It is as easy as that. Let us discuss about the travel time and delay studies. Now, this travel time and delay studies measures the average travel time which is running over the section of the road. When the same time information regarding the location, cause and delays are collected. You have learned in the moving observer car method that the delays, cause of delay, location data, all these things are collected. So that was also the part of moving observer method. Now the difference in running speed and journey speed, you already know that in running speed, what we do, we exclude the delay, and in the journey speed, we include the delay. So what is the purpose of this travel time and delay study? To collect the data for amount, cause and location of delay, and to know the congestion spot, that okay, these are the places where main congestion occurs. Then to compare the various roads and access quality, to find the efficiency of the roadway, to find out the benefit cost ratio. Benefit cost ratio means to check whether this road is providing revenue to the government as well as whether it is providing benefit to the people or not. That is called as benefit cost ratio. That is also called as feasibility survey. Then to determine the need of the traffic signal, and based on the speed delay characteristic, the traffic assignment can also be done. There are two types of delay. One is called as fixed delay and another one is called as operational delay. Fixed delays are the delays which you cannot avoid, in which the traffic volume and interferences are not playing any role. These are due to various kind of structures such as traffic signal, stop signal, red road crossings, such kind of things. And operational delays are the delays that are caused due to the delays, that are caused due to the congestion, that are caused due to the traffic volume and interferences. That involves turning vehicle, congestion. If vehicles are not parked adequately on the road, they can cause the congestion. So these are the things. Then two types of delay are there: stop time delay and travel time delay. Stop time delay is the time period that a vehicle is actually standing still. Still means that it is standing. It is not in the movement. It is not in the motion due to any of the factor. And travel time delay stands for the delay which is caused by the acceleration and deceleration in addition to the delay. Means if the vehicle is standing, that is the plot of stop time delay. If you are traveling on the road and due to traffic you are accelerating the way, then you are slowing down your speed, and that is also causing the delay. That is called as travel time delay. So this is all about travel time and delay studies. Go through this lecture thoroughly. Thank you so much.